Hello Bulgaria, hello Varna. I'm happy to present about Kotlin today to you at this drive-in conference. My name is Anton Arhipov and I'm a developer advocate in Kotlin team at JetBrains. And my job is to learn about Kotlin from Kotlin developers and tell about it to other developers. And this is what I'm going to do today. So today I'm talking about idiomatic Kotlin. And by the way, if you are watching this presentation and you want to ask any questions from me, this is my Twitter handle right here on the slide. So you can always DM me on Twitter or, just mention me. And let's start. Kotlin is a relatively young programming language. It's only turned 10 this year. But it's a good time to start thinking about the best practices and how to write programs more efficiently. And we are actually working on improving our documentation for this specifically. If you go to the website, you will find that there is a whole page about various idioms, how to implement something in the language. And we are working on adding more. If you start programming Kotlin after Java, it feels like there is a lot of syntactic sugar. And there really is. If you go and look up for the features that the language provides compared to Java, some of the features are really just a syntactic sugar, like primary constructors, delegation, singletons, anything like that. And but this syntactic sugar at the end provides you a good combination to write more readable and safer programs. Let me show you the ultimate example of how the idiomatic program looks in Kotlin. Kotlin is really well known for its ability to create DSLs, and this is one example of that. It looks really like a configuration, like a JSON, right? And we can see a few language features in there already, like Lambda with the receiver, property access instead of setters or getters, extension functions, string templates. We are going to talk about those features later in the presentation, but this is the example I want to show you immediately so that you get a feel of how idiomatic it could be. So if we talk about idiomatic use of the language, it means that it's using like idiomatic expressions, and we are using the language in the most efficient way. So it's not that it's something regulated by the compiler or any specific rules. It's just the commonly accepted style that the community have come up with. And well, it obviously needs to provide some benefits as well, like okay, we can write something in the idiomatic way, and then it's safer, more readable, more efficient, more performant, something like that. So you get some benefits out of using the language features idiomatically. The first language feature I want to talk about are the top-level functions, and more specifically the extension functions. The fact that we have top-level functions in the language changes the way we structure our programs, and I think it's worth talking about this feature in first place. So we can create functions, we can call the functions, we can pass functions as parameters, and until we just describe the behavior of the program, we don't need classes at all. We can start introducing classes only when we actually need to model the domain somehow. So don't create classes just to hold functions. We can have functions on the top level and introduce the classes later. For instance, when we program in Java, when we need a static function, we put it into some util class, right? And this is like a commonly accepted style in Java programs. So when we start programming in Kotlin, it might be that when you need a static function, or you think you need a static function, You create a util class again, and you learn from the documentation that there is no static keyword in Kotlin, and then you need to introduce a companion object. So this is what you end up with. You create a class, you create a companion object, you put a function in there. But then you read further and figure out that there is a pattern for singletons in Kotlin where you can just specify the object instead of companion object, and you create an object and put a function in there. However, you can just create a function in a top level without creating a class or any objects. And then if you need to operate on a specific type, you can actually create an extension function for that specific type to be used in the scope where you need it. And it's pretty legal to ask the question there whether you need to create a function or you should create an extension function instead. There are some suggestions what to do in this case. You can use extension functions liberally. We don't limit you on how you use them. However, it's advised to restrict the visibility of extension functions to minimize API pollution. So you can actually, as necessary, use local extension functions or member extension functions or even top-level extension functions with some private visibility or internal visibility. Some teams have specific rules that then they code into static analysis that, for instance, if you declare an extension function in one package, then this extension function should be used only in that specific package, but not in the other packages. Related to the extension functions, one language feature that I'm really excited about, and it's not implemented yet, is the context receivers. This will allow us to control even better how extension functions are used. For instance, we could declare an extension functions, and using this new language feature, we could tell that this specific function should only be visible within a context of a specific object. So let's get a little bit more practical. You know Spring Framework, it's our beloved web framework in Java ecosystem, and it can be used with Kotlin, and it actually provides a lot of extension functions for Kotlin developers to use the framework more conveniently. So let's take a look at this example here. You know JDBC template. I've been using it since 2004, and it's a very awesome API. It's so easy to use. It has changed the way I've been working with databases. And well, there is a query method. It takes some parameters. The first one is the query itself. Then there is an implementation of the role mapper and a list of parameters. In this case, we just have one parameter. It comes from, it's a standard API that we have. And but when we use Kotlin, we can actually switch the place of the parameters to have lambda in the last position. It's not possible in Java because var args should be in the last position in the method signature. But in Kotlin, we can do that. And this allows us a few interesting things. So for instance, we can move out the lambda, that is actually the direct mapping from the functional interface in Kotlin. We can move this lambda out of the parentheses. So it looks like a callback. We call a method, we put the parameters in, and then we have sort of a callback after this. And if I reformat it, it looks like this, right? It looks very fluent in Kotlin. And this is what we call the idiomatic style, the Kotlin idiomatic style, because we can write the lambda out of the parentheses when we provide the arguments. But wait, this is not the original function then, right? However, it's provided in Spring Framework as an extension function in Kotlin. So it's an extension functions to the JDBC operations class, and we can use that to write more beautiful programs when we use Kotlin. In fact, if you look into the standard library of Kotlin, you will see that a lot of functions are provided as extension functions, and the brightest example there is the scope functions. This is the set of functions that are extensions to any type, and the whole purpose of those functions is to execute a block of code within the context of an object. There is 5 functions that we call scope functions. It's let, run, with, apply, and also. And we have a very good documentation about those. You can find the examples in the documentation. And I will cover just a few use cases where I think the extension functions are very commonly used. So, for instance, when we initialize objects, we can declare a variable, and then to assign various properties, we would access that variable on each line separately. And by using the scope function, like also, for instance, we can execute the block of code within the context of this variable. So we don't have to access this variable to assign a property. So this way we kind of get rid of verbosity, and we group the object initialization in one place, in one block. And this makes the program a bit more readable, I think. So this is the standard library function. And if you look at the definition of this function, it's an inline function, it's an extension function, but it also takes an argument that is a block of code that executes within the same object at which we are invoking this function, right? So the lambda argument that we provide as a parameter executes within the scope of that specific object. So implicitly, this variable inside that function refers to the same type, to the same variable that we are calling this apply function on. Another very commonly used example is the let function, when we use it to check for null value. So for instance, we retrieve an order and we want to do something with that order, and it might be null. Maybe it's declared even as a nullable type. And then we check for null and we refer to that variable. In this example, for instance, we call a customer property on that variable. And in Kotlin, we often write it like this. We use the save call operator to run an extension function, and then in that block, we just refer to that variable that we don't declare this time. We refer to it as an implicit variable with the name it. So the difference here is that we don't declare the variable. We don't need the intermediate variable to actually do something with it. So in the documentation, you will find a nice reference about all these functions. What is the implicit variable in the scope of the lambda that is used as a parameter? Is it an extension function? And what is the result of the execution? However, when people learn about scope functions, one thing that they do incorrectly, I think, is start overusing them. For instance, this example here, when we create a directory and we provide a path that we should use to create the directory, and this is what you can come up with when you just start using the scope functions. Let's compare to to the example when you wouldn't use the scope functions. Like this, right? It's more readable. It's a simple code. We declare a file variable, we call the function to create the directory, and we return the file. Well, okay, it actually can be written a bit easier like this. When we use the also function, we create a file and also create directory. The two features that play really well together in Kotlin is the ability to define a default value for an argument of the function or a constructor, and the name parameters. So in Java, when we need to provide the default parameters, we use overloading. For instance, here we have a find function, and we have two versions of this function because we want to provide a way to use the default value for the second parameter. And in Kotlin, we can just define the second parameter with the default value in the function signature. However, when we have a long list of parameters, like in here, we have a class figure, and then we have 5 parameters, and we want to just specify a different color in the description, then it wouldn't work. It would be a compilation error because the compiler doesn't know which parameters it actually should use. However, with name parameters, this problem is resolved. We can just explicitly say which parameter we are assigning to. And it makes your code readable even if you don't use the IDE, because if you are doing code reviews, for instance, it would be much easier to understand which parameter you are actually passing into the function. So the outcome of this is that the default arguments diminish the need for overloading functions or constructors. And the named parameters is a good addition for using this feature. Let's talk about null safety now. I think it's the single most important feature of Kotlin language, where we can distinguish between the null values and the values that cannot be null. For instance, if a function can return null value, we can annotate the return type with the question mark, and then the compiler can detect the situation, and in case the reference to the object is a potentially null value, it will raise the error and force us to handle the situation correctly. But it's not enough to give the null safety on the type system level. We need the operators as well to work with it efficiently. For instance, if we work with deeply nested object structures and we want to reference some property that is deep down in that object graph, we would need to handle all those intermediate references as well and check if they are null or not. And we can use the safe call operator to actually express this intent in a more concise manner. And it's really efficient in the combination with the Elvis operator. And Elvis operator is also a very idiomatic operation in Kotlin when we have to check for nulls. For instance, if we want to provide a default value, here is the example. We retrieve a person and it might be null. And if it's null, then we provide a default value. Or we can use the Elvis operator as a shortcut for return and throw statements. Like this. In this example, we have a condition. If name is null, then we raise an exception. Or if the age is null, then we return from the function. So we can replace the statements to use Elvis operator instead. And here how it looks like. The function now is more concise, and I would argue that it also is more readable. Time to talk about the standard library. This is my favorite part actually, because someone has already written the code for me and I just have to use it instead of inventing my own bicycles. In fact, me and my colleagues are putting a lot of effort into the Idiomatic Kotlin series that feature a lot of standard library functions. And if you're interested, you can read about it in our blog. And also we put up the YouTube videos where you can find the same solutions explained by me and the others. In this part, I would like to bring you some examples by explaining a simple task that is actually one of the tasks provided by the Advent of Code challenge last year. So in this task, I have to count the characters in the strings, and the strings are in the file. and each string represents a set of answers by a single person. And the answers are grouped within the file and separated by a blank line. So this is how it could look like. We have first group where we have 4 strings, and the second group where we have 3 strings. And the requirement is to count all the characters that are present in every line within the group. So in the first group, that will be the character D, and in the second group, that will be X and Y, meaning that we have 1 character in the first group, and in the second group, we have 2 characters that count. 1 plus 2 equals 3. That's the total. That's the answer we should give. So how do we implement that? So instead of just to simplify, instead of reading the file, I have this input as a string. So to break down into the groups, I will split it by the empty line. And I can see that in the debugger that I have a list of strings, and each string is a single group. And within a single group, I have multiple lines separated by the new line character. So in order to calculate the answer, I have to iterate over the groups, split each group by the new line, and the simplest solution is to convert every line into a set. And then to find the final answer, I would iterate over all the sets and find the intersection to keep only the characters that are present in all the sets. And finally, I have to take the count and sum it up. In fact, in this loop, we have 2 sections. The first section is transforming the data before the calculations, and the second part is where we actually calculate the result. So how could we do that a little bit differently, and which functions from the standard library we could apply here? So for transforming the data, we have this first step. We split all the groups by the new line character and convert them to a set. So we end up with a list of lists of sets of characters. So that's exactly the mapping of the previous solution where we iterate over the groups, but we use the map function instead. But the operation itself stays the same. And then to calculate the result, we actually would use the reduce operation and sum of operation for the collection. Let's see how does it map to the previous solution. So we use sum of instead of iteration and summing up. And we use the reduce operation instead of iterating over the sets and applying the intersect operation. For that, we are actually using the intersect operation in the lambda for the reduce function. And in fact, we can chain those 2 operations together to form this transformation and calculation pipeline. If you want to read in more details, you can read it in our blog post about this specific task and watch the video on the YouTube channel as well, where I explain this task in more details. Okay, let's get back to where we started. Kotlin is a very convenient language for creating domain-specific languages where we can just use the idioms from the language and end up with something that looks like a domain-specific language, but it's still a valid Kotlin code. Here I will show you one more example from the standard library. For instance, this build string function looks like a small DSL for building the strings. In fact, it's just a direct mapping into a string builder operation that you would write in Java, but it's more concise and more readable. Another example is the Kotlin X HTML library, where you can use the functions that are provided by this library with the nested blocks inside blocks to compose HTML documents. Or one more example is the Ktor web framework, where you can intermix the Kate or DSL for routing, with the Kotlin XHTML library DSL for building the documents. As you can see, we have two DSLs in the same file, and it's all the same valid Kotlin code. One example that I want to demonstrate to you is how those small DSLs contrast with using the builders from Java language. Here is a simple example. We have a client builder, a Twitter builder, a company builder, and then we build up a client object using those builders. This is a very simple code. Everybody can read and understand it. There is nothing wrong with it, but you actually have to spend time reading it to figure out what it actually does. We can convert it directly to Kotlin. It will be a little bit more concise, but it still is a plain page of code that we have to read line by line. But using those idioms that I have demonstrated to you in the previous slides, for instance, using the scope functions, trailing lambdas, we can create a structure for those builders. And by extracting the domain-specific functions for this specific task here, we would end up with a very clean and nice code structure that is very easy to read, because the code is very minimal, it has a structure, and most importantly, it's type safe. So I hope you have learned something new and useful today, and if you haven't tried Kotlin yet, I hope I'm motivated to give it a try. So enjoy your evening and have a nice Kotlin.